Good morning, students. Today we are just starting with the new chapter of alkaloids. This is pharmacognosy and phytochemistry in that alkaloids. So here in this slide just I have shown you some of the picture which denotes the coffee and the morphine injections, chocolates and a flower and a syrup which is also denoted. So you see alkaloids are present in a variety of products which is available. So for medicinal use, and we are depending on various type of alkaloids. So just to show you an introduction. And now we will come to the definition. Alkaloids, difficult to define, do definitive difference between an alkaloid and a natural occurring complex amines. So complex amines will also have nitrogen. So when you say nitrogen containing compound, so what is the difference between them? That's why we use that word. It is difficult to differentiate alkaloids from natural occurring complex of amines. Alkaloids, plant derived, and alkali, that is basic, and contain at least one nitrogen atom. They also normally have a significant physiological action or a pharmacological action or a therapeutic action on humans and animals. Protoalkaloids, aminoalkaloids applied to compounds which lack one or more of the property of typical alkaloids. So some of the compound which have the nitrogen in the ring or in the outside, and it may be having the compound will be having the nitrogen atom, but they may not give a positive test results which the true alkaloids give. So protoalkaloids or aminoalkaloids applied compounds which lack one or more of properties of typical alkaloids. Other alkaloids do not conform with the general definition or synthetic compounds not found in plants but are very closely related to natural alkaloids. So you see I made two structures in this slide to show you that is nitrogen inside the ring, how it can be in a 2-benzene ring or you can say naphthalene ring containing nitrogen, that is quinol derivatives all will come in this form, and also you can see there is a benzene ring with nitrogen, that is pyridine, and also a pyrrole ring with a nitrogen you can see which is it's somewhat nearing to the nicotine structure. So simply show that nitrogen should be present in the ring structure for alkaloid. So description, when you come to the description of alkaloid, contains nitrogen usually derived from an amino acid, bitter tasting, generally white solid, exception is given to nicotine. It is brown in liquid in nature. And see the nicotine structure which we just I told basic as CH3 is present in the 5-membered ring structure. They give a precipitate with heavy metal iodides, that is alkaloid. Generally alkaloids will give precipitate with heavy metal iodide. So when you come to the chemical test, all of them will have iodides. So you should remember that they have a chemical reaction with iodides, metal iodides. Caffeine, a purine derivative. You should remember caffeine is a purine derivative. A purine derivative, you can have a 6-membered and a 5-membered ring with 4 nitrogen as shown in the picture. And also you may be knowing purines, how they have the structure. So inside they have nitrogen. Does not precipitate like most of the alkaloids. That is the problem. They does not precipitate like most of the alkaloids. Alkaloids are basic. They are always bases or alkali. They form water-soluble salts. Most alkaloids are well-defined crystalline substances which unite with acids to form salts. In plants, they may exist in the free state as a salt or an N-oxides. So students should know what is a free state, what is a salt state, what is the N-oxide states. These all things you have to go through and you have to refer. You know, these handouts are just condensed one. So you have to elaborate it, some of the knowledge away from the handouts and away from the PPT which I am giving. Occur in a limited number of plants. Nucleic acid exists in all plants, whereas morphine exists in only one plant species, opium. So some of them occurs in one plant species only, it cannot be seen in another. But if you see there are some secondary metabolites, you can see in some families together, sometimes different plants also we can have some secondary metabolites. So test for alkaloids, you see in this test for alkaloids, as we have told in the previous slide itself, they have reaction with iodine metal salts. So you see all the reagents which we are using have some relation with iodine metal. Most alkaloids are precipitated from neutral or slightly acidic solution by number 1, Mayer's reagent. What is Mayer's reagent? Potassium mercuric iodide solution. Potassium mercuric iodide solution. When you add with alkaloid, immediately they give cream colored precipitate. You can see the picture, creamy colored precipitate you will obtain. Drag and draft reagent. It's a very important reagent which we will come across for identification of alkaloid, even in TLC, paper chromatography, spraying reagent and all, we will be using the dilution, everything you should know how to prepare this reagent, also very important for the student. So what is the drag and draft reagent? Solution of potassium bismuth iodide. What color it is giving? Orange color precipitate can be identified, can be visible when alkaloid is added with drag and draft reagent. Wagner's reagent. What is Wagner's reagent? It is iodine in potassium iodide. Red brown precipitate. You can see it's a red brownish precipitate you will be attained. And then Hager's reagent. What is Hager's reagent? Picric acid. Picric acid means immediately we know that yellowish color. So yellow precipitate as shown in the picture you will obtain. So all this reaction will not be obeyed by caffeine. Caffeine does not precipitate, but it is an alkaloid. It is a purine derivative. When you come to a structural relationship, we will see it is a xanthine derivative and it has alkaloid character, nitrogen is present, but still they will not obey this qualitative test for alkaloids. So by this we can understand there are some alkaloids which will not obey this alkaloidal qualitative tests. An occurrence and distribution and location of alkaloids occur in bacteria, example Pseudomonas aeruginosa, and rarely in fungi, psilocin from hallucinogenic mushrooms. There are mushrooms will give hallucination, euphoric condition, flying feeling can also be obtained from some mushrooms. Some alkaloids occur in several genera from different species, like caffeine. You can see in tea, you can see in coffee, you can see in coca. There are many places you can identify caffeine. So in several genera, different species may also be present. Caffeine is an example. But most occurs in closely related species. If you see, they are some of them closely related species. Some occur in certain families like hyoscyamin, atropine. These all are present in Solanaceae family. Some families, when you compare, or Apocynaceae family, like that, some families they will be having hyoscyamin, while others occur only in specific species like morphine. It is only present in opium. Rarely do plants contain more than one type of alkaloid. Rarely, but there are more than one alkaloid present even in very important antihypertensive drug Rauwolfia serpentina. They also have 2-3 alkaloids. So rarely do plants contain more than one type of alkaloid. All alkaloids of one plant will have a common biogenetic origin. A common. They will be having a common biogenetic origin. Alkaloids occur in all plant parts but are usually localized in one organ. Maybe a bark, maybe a seed, maybe a leaf, maybe root, maybe stem. So you can see any one part, it will be localized. But we cannot say some plants will have almost all the parts. Some of them, the exact secondary metabolites which we need will be more localized in a part of the plant. Within the plant, alkaloid can vary widely from part to part. Some part may contain no alkaloids. Some part may contain more alkaloids. Occasionally, different alkaloids also form at different parts of the plant. Occasionally. That means sometimes leaf will have one alkaloid, root will have one alkaloid. This also by means of their biosynthetic pathway and their storage deposition in the cells of the plant, it may differ. Occasionally. Alkaloid concentration occurs in wide range. Example, Madagascan periwinkle contain 3 grams per alkaloid per ton of leaves. It's an anti-cancer drug which will be present in it. So you see, very little quantity. 1 ton of leaf you have to take, or you have to use for extraction to get 3 grams. So it is very less amount in certain plant and which is having more use. You can see the picture of the vinca. The nitrogen of alkaloids can be, atom can be either primary, secondary, tertiary or quaternary nitrogen. Nitrogen features affects the alkaloid derivative which can be prepared and by means of isolation procedure. So now we have to know about how we are going to isolate or how to know about the things. Before going for isolation, we should know the physicochemical or physicochemical properties of alkaloids. A pharmacist usually should have an idea of physicochemical properties of any compounds before manufacturing any formulation. So here also, when we are talking about an alkaloid which is present naturally and it has many medicinal uses, we should know about the physicochemical properties of alkaloids, in which molecular weight vary from 100 to 900. Most bases which do not contain oxygen are liquid at room temperature, example nicotine, while those do not are solid. In rare cases, they are colored. Most solid bases rotate the plane of polarized light. So this I told you to remember about the polarized light. What do you mean by rotation? You might have studied in your organic chemistry according to the configurations. Optical rotation, optical isomers. So when plain polarized light fall on an object, a compound which is having a chiral carbon atom, which have different substituent in one carbon atom, it will have its own rotation in the plane of rotation when a light falls. So that you can say dextrorotatory, levorotatory, like that you might have studied. And there are isomers, L isomer, D isomers you might have studied. So that also plays a major role, and physical properties and therapeutic effect also differ by means of their optical activity and have high melting points, normally are not soluble in water, occasionally slightly soluble, soluble in apolar or slightly polar organic solvents. Here in this junction, you should know what is apolar, that is non-polar solvents, or slightly polar solvents and polar solvents. So series of polar solvent system, and polarity of the solvent system is very important for a pharmacist when he is coming to pharmacognosy and other chemistry subjects, when he going for any extraction or any type of identification, any type of laboratory work he should know. So when you see, I am simply telling only few solvent system, like when you see low polar solvent hexane, petroleum ether, benzene, acetone, ethyl acetate, ethanol, methanol, dilute acids, water and dilute acids. So like that you can say that is from low polar solvents to high polar solvent, like that. Now I have told only a few. There are many solvents with minute difference in their polarities, which will helpful for you to do many experiments to isolate and to separate compounds, and for identification. This solvent system, knowing about solvent system is a very important factor for any pharmacist who try to study about the presence of secondary metabolites, or to isolate or to separate the secondary metabolites from a crude drug. So soluble in concentrated hydrochloric or hydroalcoholic, not hydrochloric, hydroalcoholic solutions. The basicity of alkaloids depends on availability of lone pair of electron on nitrogen atom. So you should know that. You might have studied this very clearly in your organic chemistry. You have to revise your knowledge. You might have studied the basicity of amines, acidity of phenols. So basicity of amines, you have to go and refer how the basicity of amines differ for primary, secondary, tertiary, how they are differing, what is its electronic configuration and these things. Basicity, what do you mean by basicity? You have to go for that study, so it will be easy. So electron donating group enhance the basicity, while electron withdrawing group decrease it. So because some alkaloids have some carbonyl group on the amide. So amide group means you should know the basic chemistry amide or CONH2. So there is one carbonyl group from acid amine joined together, then you are getting amide. So carbonyl group, when there is present a carbonyl group C double bond O NH2, there is a carbonyl group, they can also neutral. So example colchicine, piperine. And basicity is also influenced by steric constraints. What do you mean by steric constraints? You should know about what you studied in the basic organic chemistry regarding geometrical isomer, cis isomer, trans isomer, and what is the steric effect of an cyclohexane, chair, boat, shape. This all you might have studied in your basic chemistry. Just refer. When a word is coming, you should have an idea what is it. And you can say basicity is also influenced by steric constraints. Basic characteristic renders complex alkaloids unstable so that in solution they are sensitive to heat, light and oxygen. Basic characters of alkaloids also allows them to form salts with mineral acids such as hydrochlorides, nitrites and sulfates, or inorganic acids even, and tartrates and sulfamates can also be formed. Alkaloid salts are soluble in water and dilute alcohols. Solid salts can be conserved well and are a common commercial form of alkaloids. Classification of alkaloids now. Alkaloids have a large variety in their botanical and biochemical origin, in chemical structure and pharmacological action. Therefore, like flavonoids, a range of different classification systems exist for grouping alkaloids. They can therefore be classified according to their biological origin, chemical structure, two division, atypical, non-heterocyclic, alkaloidal or alkaloids, proto-alkaloids or biological amines. Number 2, typical heterocyclic alkaloids divided into 14 groups according to their ring structure. Then even it can be divided by biosynthetic pathways also, it can be classified. So now we are coming to naming of alkaloids. In naming also, something which you should have a discussion, many names. For example, numerous methods can be used to name alkaloids. Generic plant name is given for Atropa belladonna, the presence of atropine. Specific name for the plant is given Erythroxylum coca, contains cocaine. Common name of the herb is given to ergot, rye plant, which contains ergotamine, which is having more activity in migraines, and also it can be used for as an abortifacient agent. And physiological action by the plant is also named, like emitin, which is used for emesis. And other example, morphine derived from ancient Greek mythology. In ancient Greek, they used to say that is god of dreams, and Morpheus is the picture which I have shown is a picture very famous in Greek. Why they kept this? Because morphine, you know very well, it is a narcotic analgesics which causes hypnotic sedate, it gives sedation, and which is more commonly used for a post-operative pain, and also it has more application as an analgesic, and also sometimes it can be misused because of its hallucination and euphoric condition. It can give a flying feeling. And also it has, morphine was used for many medicines previously. 3000 years back itself, the morphine was more used, and opium was more used for various purposes. Even we know that in cholera, when it is very high, you have to go for even liquid opium will stop the dysentery. So it has many use, not only apart from the sedation and analgesic effect, it has many uses. So that's why they are used as a god of dreams. And this is a structure just to show the students, because you know structure of natural compounds, when you are studying, it is necessary for you to write chemical structure clearly in pharmacognosy. Then only you will get the exact mark when the teacher evaluate. So you see, morphine is present in opium. We are having the opium drug, clearly we will study. So before going that itself, if you see this structure, it's very easy. It is having a phenanthrene ring, 3 ring structure, which is an outside N methyl group, and also OH groups are present. So what is the difference between morphine and codeine? Yes, simple. In the third position, OH is just substituted by CH3, OCH3. A methoxy group is present in codeine and OH group, phenolic group is present in morphine. But you see, a small change in their substitution, it has a great therapeutic effect different. So this is what you might have studied in your medicinal chemistry. Very strongly you will be studying structural activity relationship. A small change in the structure, it gives totally a change in their therapeutic activity. You see, morphine is used as an analgesic and it is more potent and non-narcotic, not narcotic analgesic. But you see, codeine is not that much vigorous. It is having just a cough suppressant and it's not having much sedation effect at all. So that's what a difference, a small difference makes them to be different. Both of them is present in the same plant. Opium, capsule, fruit, exudate. And you can see the extraction of alkaloids. Extraction is based on the basicity of alkaloids and on the fact that they normally occur in plants as salt, on the solubility of bases and salts in water and organic solvents. Herbs often contain other materials which can interfere with extraction such as large amount of fat, waxes, terpene, pigments and other lipophilic substances by forming emulsion, avoiding by defatting the crushed herb by using petroleum ether and hexane. This is the point where the student should understand. The fat substances may be present in the plant which will interfere with all your experiment when you are isolating the alkaloid. So how to remove these fat substances? How to remove these lipophilic substances which may be present in the plant? How to remove these waxes? How to remove these pigments? How to remove the terpenes may be present in the particular alkaloidal plant? It is possible for you to remove by means of using hexane or petroleum ether, low polar or non-polar, least polar solvents such as petroleum ether, hexanes can be used to remove the fatty substances which may be present in the herbs which are interested for your extract, which you have taken for isolate alkaloids. So that process is called defatting. So sometimes anyone can ask you a question, how will you defat from a plant material or a crude drug for your research work? How will you separate them before going for your original extraction? So you have to remove immediately. The fats can be easily soluble by means of low polar solvent system like hexane or petroleum ether can be used. You have to have in your mind this point. And alkaloid extraction continues. The extraction method normally depends on the raw material. How the raw material, whether dried one or fresh one, or this also depends, and purpose of extraction, whether it is for small scale, for a research, or for a large scale, for any type of production or formulation. So by the scale for which it is according to the scale, you are deciding what type of procedure can be followed for the extraction. For a research purpose, you can go for chromatography, allows for quick and reliable result. Chromatography is a very important chapter even for the pharmacognosy. You might have come across in chemistry also. You will be coming across various area even after your degree. When you are going for PG or PhD, you will come across this chromatography technique. So chromatography, what do you mean by chromatography? Anyhow, we will be studying in detail in the chromatography, but here I want to say something, at least the definition to further understanding. Chromatography means separating of mixture of compounds. It is a technique used for separating of mixture of compounds. And you should know that chromatography, you might have studied in your chemistry also, basic chemistry. There are two principles of chromatography. There is adsorption chromatography and also partition chromatography. They are principle behind, and there is techniques. There are many techniques which can be followed by thin layer chromatography, paper chromatography, high performance liquid chromatography, gas chromatography, gas liquid chromatography, gas solid chromatography, Sephardex chromatography, gel permeation chromatography, gas chromatography with mass spectroscopy. So there are many type of chromatography which is used for separating the compounds and to isolate them and to identify them. And you will study in detail in many subjects, especially instrumental analysis. In that you will give more detail about the instruments and how it is applied for identification and the isolated compound, and to elucidation of structure can be easily identified. And if large amount of alkaloids needed to be extracted, you can follow the following methods from the next slide. This slide shows extraction in an alkaline medium. You know that alkaloids are basic in nature or alkaline in nature. They are powdered, defatted. First step itself, defatted by means of petroleum ether or hexane, is mixed with an alkaline aqueous solution. Now it is mixed with an alkaline aqueous solution. This displaced alkaloids from their salt combination. So when you add this alkaline aqueous solution to the defatted mixture of your crude drug, what is happening? Displacement of alkaloid from their salts combination will occur. Free bases are then extracted with organic solvents. Now you can go for extraction with organic solvents. Normally aqueous ammonia is used, but means what is then any other idea? That means a carbonated solution is used when alkaloids contain fragile elements such as esters or lactone. There are alkaloids which contain esters or lactone. So when they have fragile elements like esters or lactone, then you have to add carbonate solution. In some cases, example cinchona bark, a mixture of calcium hydroxide or sodium hydroxide should be used, as the alkaloids are bound to tannins in this type of plants like cinchona bark. Organic solvents like chloroform, dichloromethane or ethyl acetate depends on their toxicity, safety, cost, easy to recovery and recycle of the solvent. You can select them. Now I am showing you that Soxhlet apparatus which you should show in a laboratory, but anyhow you can see this is a picture drawn and this is the original photograph of a pilot or a small 250 ml capacity of Soxhlet apparatus, which shows a round bottom flask, a Soxhlet apparatus, or it can be called as extract chamber or extracting tube, and above which is fixed with an condenser, water condenser. So this is the three parts which is shown here in a Soxhlet, which works in a principle of counter current extraction such as Soxhlet apparatus. So you might have studied about many type of extraction in your pharmaceutics like percolation, maceration, and in that percolation, hot percolation, cold percolation, maceration, double maceration, triple maceration. Like that you might have studied very different topics, menstruum, press the mark, and to take the complete extract and remove the solvent system. The residue can be used for various purpose of identification of that particular compound which is present in that extract. So that is the important application of your Other subject you have to apply in the next advanced subjects. So you remember that. So what type of extractor is this Soxylate? Soxylate is an continuous hot percolation method. When you see the procedure, you will know that continuously hot solvent moves through the sample and extract the compound, and it will be collected in the round bottom flask. You can see that. Now I am just showing that picture, enlarged picture which we have seen in the previous slide. There is a heating source, mantle can be used, organic solvents which will be used according to the selection or the monograph, round bottom flask, and solvent will evaporate, and you can see the arrow, and it goes to a side tube. Can you see the side tube? The arrow is given, only vapors will go through the side tube, and it goes to the condenser, and it condenses down back to the sample area where it is kept. Now I am coming to the picture. There it is shown that it is sample and sodium sulfate and glass wool. It can be kept, or sometimes you can keep in a bag, or sometimes you can simple sample itself directly can be kept. And then you can see cellulose can also be kept over it, and you can see there is a mark of reflex side arm. It's called reflex, not, but actually it is called siphon tube, or it's a small tube which brings the solvent system back to the round bottom flask. Remember that? It is written there, reflex side arm. It can be called a siphon tube which will bring back the solvent system from the extracting tube or from the Soxylate apparatus back to the round bottom flask. What is the side tube which is putting arrow? It takes the volatile vapors from the solvent system to the condenser and comes back to the sample for the extraction process. And you can see there up again condenser, and there is an inlet and outlet for water. And this is the original picture of a pilot Soxylate apparatus. Series of Soxylate apparatus can be used for research purpose. You may use many samples, many extractions can be done by in a series, with series of mantle, series of round bottom flask, and series of Soxylate apparatus or extractor which is fixed with in the top a condenser, water condenser. Now you can see this video, just a working principle of Soxylate apparatus. See, there is three parts: a round bottom flask, a Soxylate apparatus, or the extractor is fixing with a ground joint. It is called ground joint in the glass, and then it can be fixed with a condenser, water condenser. There are three parts, mainly three parts. A glassware which can be kept in a round bottom flask is kept in a heating mantle. You see, this is heating mantle, even temperature can be controlled. Heating mantle fixed with a Soxylate apparatus. There is a side tube, and also there is a siphon tube. You can see the reflex siphon tube. A small tube also is there. A side tube is also there which takes the vapors. Solvent is already poured in the sample. But there is the fixation of condenser, water condenser. There is an inlet and outlet with a rubber tube, and this will be fixed with the tap water, and tap will be open, and the speed of the tap water flow will be controlled. It should not be very high, it should not be very low. Uniformly cooled water, the tap water should run through the condenser so that it will be cool over there for condensing the vapors which is coming from the side tube. See that he is controlling the flow, and then you are using funnel in the top of the condenser, pouring the solvent system to the round bottom flask. How it will come? It will not come directly. It will come to the sample, and it will just, the level of the solvent system increases up to the siphon tube or the reflex tube. You see, there is a small tube not the side tube. There is a small tube. Both of them are in the same side, but in the diagram we showed in the two sides. But you can see both of them. One is small tube, which is siphon tube, or the reflex tube, which brings the solvent towards the round bottom flask. Once it comes to the level, see now how it is siphon. Siphon. This is called siphon. Completely the solvent system will come to the round bottom flask. If it is a 250 ml or 500 ml, it's a 500 ml. You can expect 200 ml minimum of solvent can be given. 250 ml or 200 ml solvent system can be filled here. Can you see the solvent which we are just filling? It comes through the siphon tube or the reflex tube, which comes back the solvent to the round bottom flask. And after you are getting the solvent system in the round bottom flask, you can go for electric system. Plug the electric system to switch on the heating mantle. Now you can see the heating mantle is on, and the temperature should be adjusted according to the solvent system which you are using. Boiling point, and then according to the not more heat or low. You can see that it should boil, and the vapors are moving through the side tube. That is what he was showing with a glass rod side tube, and it goes to the top of the condenser and condense back, dripping down. You see dripping down. The condensed solvent system is dripping down to the sample, and there the extraction process takes place. It soaks the sample and extracts, and when the level of the solvent moves up and up and up, when it comes above the siphon tube, see the glass rod is showing the siphon tube. When it is above the siphon tube, it gets a pressure. It gets a pressure of siphon. It gets the Pascal's law. It just gets the pressure. It just moves and drifts down and drains all the solvent back to the round bottom flask. Can you see that? Now you see it start moves. Yes, it start moves and comes back to the round bottom flask. Again the solvent alone is evaporated, goes through the side tube, and it drifts down, and the solvent is continued. That is why it is called this. See, again it goes and drifts down, and that is why it is called continuous hot percolation method. This extraction is called as continuous hot percolation method. That is why it is called continuous hot percolation method, which is used for various extraction method in the research purpose. The capacity of this one differs, sometimes 250, 500, 1000 ml, and bigger isoxalate apparatus is also available according to the quantity which is interested for you to extract. So this is what the specific isoxalate apparatus, how it works, and afterwards cleaning and everything, brackets will be removed and the solvent system will be taken out, and then you will evaporate it, and then the residue will be used for various chemical tests. So extraction of alkaloid in the second step, organic solvent containing these alkaloid bases are separated from the round bottom flask from the residue concentrated by distillation under pressure is needed. Because why you want distillation under pressure or vacuum? So because you can reduce the heat which is used for the solvent system to evaporate, because our components may not get deteriorated by means of there may be thermolabile substances which may be deteriorated by means of overheating. So that can be avoided, so that you can use this type of technique by controlling the pressure. You can go for distillation. And solvent is stirred with an acid aqueous solution. Alkaloids go into the solution as salt. Impurities remain in the organic phase, repeated until the organic phase is no longer contain alkaloids. Many acids can be used: hydrochloric acid, sulfuric acid, citric acid, tartaric acid can be used, but always this very dilute concentration is used, 1 to 5%. is advisable for performing these experiments. Alkaloid extraction in step 3. Aqueous solution of alkaloid salt is washed with an apolar or non-polar solvent like hexane, alkalized with a base using organic solvent not miscible with water. Alkaloids precipitate and dissolve in organic phase. Extraction of aqueous phase continues till all alkaloids have removed into organic phase. Tested when Mayer's reagent on the aqueous phase becomes negative. That means there is no alkaloid is present. Up to that you have to extract. And this purification step may be carried out in a separating funnel as shown in the picture, or in centrifugal extractors can be performed. Final step, the organic solvent containing alkaloid base is decanted, freed from water, traces drying over anhydrous salt, sodium sulfate, and evaporated under reduced pressure. A dry residue contains total basic alkaloids. Alkaloid extracts in acidic medium. Two methods possible. Pulverized drug is extracted directly with acidified water, or pulverized drug is extracted with acidified alcoholic or hydroalcoholic solution. This is then followed by distillation under vacuum, eliminates that alcohol, leaving behind an acidic aqueous solution of alkaloidal salts. This is just show you the picture of a distillation chamber. You can just go through it. In both cases, results aqueous solution of alkaloid salts needing purification achieved by alkalizing solution and extracting bases with an immiscible organic solvent selectively absorb the alkaloids contained in the solution on an ion exchange resin, then eluting them into a strong acid. So ion exchange resin means, again the student should know what is the use of this ion exchange resin. There is ion exchange chromatography is also available. There are resins which has a capacity to separate anion or a cation. So anionic resin, cationic resins are available. So which can take the anion and they can be separated. Afterwards you can elute it by using strong acids from the compound can be taken away. So that is the capacity of resins. That is why it is called anion type of resin, cation type of resin, and they will be using anionic resin, anionic type of chromatographic, cationic chromatographies are available. So precipitating the alkaloids as iodomercurates, the resulting alkaloids are recovered by filtration, dissolved in a mixture of water, alcohols and acetones, and decomposed by passing through an ion exchange resin. This is just a picture to show you the ion exchange chromatography, how an ions, you can see hydrogen can be replaced by sodium, and sodium can be again, you can remove it by means of next step, so that you can just isolate any cation. If you are using an anion type of resin, even you can go for anionic exchange of resin. Ion exchange, it exchanges the ions, can be done by this technique. And isolation of alkaloids, all methods of alkaloid extraction yield impure compounds. So alkaloids therefore have to be separated by TLC thin layer chromatography or high performance liquid chromatography are most commonly used. Under the best condition, alkaloids can be obtained by direct crystallization simply by neutralizing the acid extraction medium. It can be performed. And isolation of alkaloids, large scale extraction may be sent to a factory for purification and separation. For cinchona and coca alkaloids, Separation and final purification may be done using fractional precipitation or fractional crystallization of salt. Chromatography is used for complex alkaloids and if only small amount of alkaloids are needed. Volatile liquid alkaloids like nicotine are isolated by distillation. Alkaloid is distilled off in steam. Nicotine is an important insecticide and large amounts are prepared from the part of tobacco plant which is not used for tobacco manufacture. Pharmacological action and uses a general idea. If you see CNS acting, stimulants, caffeine or depressant, morphine, and in ANS acting, sympathomimetic or adrenergic, ephedrine or sympatholytic, yohimbine, ergot alkaloids, parasympathomimetic, pilocarpine, anticholinergic, choline, and ganglioligic, ganglion acting, nicotine, and also local anesthetic, cocaine, defiltration, quinidine, anti-tumor agent, ellipticin, and anti-malarial quinine, antibacterial, and berberine, and amebicides like emetins are the examples. There are many, but we have taken only few to show you. In pharmacological action also we can differentiate or we can classify the alkaloids. And alkaloids can be easily classified according to their amino acid responsible for their productions, like ornithine, which can produce tropane alkaloids, pyrrolidine alkaloids, pyrrolizidine alkaloids, and tyrosine can give rise to benzyl isoquinoline alkaloids, and tryptophan can give rise to indole alkaloids, quinoline alkaloids, and pyridine can give rise to pyridine alkaloids, and lysine can give rise to quinolisidine alkaloids, and piperidine alkaloids can also be produced. And in chemical classification, this is the most acceptable way of classification of alkaloids, which basically depends on ring structure present in the alkaloid. The alkaloid drugs are broadly categorized into two divisions: true alkaloids subdivided into 12 groups, and proto-alkaloids are biological amines and pseudo-alkaloids. True alkaloids you can see pyrrole and pyrrolidine, hygrine, coca species example, pyridine and piperidine, arecolin, anabasine, conin, and trigonylin, and pyrrolizidine example ichimidine and symphytine, and tropane example piperidine, N-methyl pyrrolidine, that example atropine, hyoscyamin, and quinoline example quinine, quinidine, chinchonin, and isoquinoline example morphine, codeine, and aporphin example reduced isoquinoline naphthalene derivative example bolidine, indole benzopyrrole example vincristine, ergotamine, reserpine, imidazole example pilocarpine, isopilocarpine, and norlupiname example cystine and spartine example, and purine, pyrimidine, and imidazole, the derivative example caffeine, or you can call as theophornine, or theobromine is also available. Theophylline is also comes under purine derivative. Steroidal, cyclopentoperhydrophenandrine ring, which can give rise with example solanidine, conicin, and next one you can have that one is steroidal, one is A is actually cyclopentano ring example and pseudo alkaloids. If you see that is pseudo alkaloids example, next one is pseudo alkaloid, the 12th one, next pseudo alkaloids, and diterpene, aconitin and aconin. And protoalkaloids example, you can see it can be called as aminoalkaloids, alkylamines, and ephedrine and colcinin. So this we are going to see this detail about the next class about vinca, plants, detail about the alkaloid present in vinca, rauwolfia, belladonna, opium, ephedra, cinchona. This all comes under the drugs which we have to see in this syllabus. We have to go through this one, and you see that chemical classification, true alkaloids 12 and pseudo alkaloid we have given one example, and proto-alkaloids. So 12th one is the last one, 12 we have given for the true alkaloids, pseudo-alkaloids and proto-alkaloids. So thank you, and we'll see in the next class.